Guys, here is rationalizing the denominator and simplifying. Okay, so we first have this 53 problem, which means that we have to multiply top and bottom by the square root of 5. Now you must be asking why. Well, I know that this square root has a root of 2, which means in order to cancel off that root of 2, everything on the inside has to have a second power. So in order for this 5 to get a second power, gotta multiply it by another 5. Okay? So we are simply gonna get 15 root 5 all over. Now, square root of 5, you guys, times square root of 5 is just square root of 25, which is simply just 5. Cancel these two, right? So then we're just going to get 3 radical 5. Right? 15 divided by 5 is 3. Okay, next. Now, number 54, you guys. Now, before I multiply by radical 18, I'm noticing that I could simplify the denominator, which I'm going to do. So, 5 square root. Now, for 18, right, if we made a factor tree, we're going to get 9 and 2 and 3 and 3. And since it's square root, gotta find pairs, so it's going to be 3 radical 2. So 3 radical 2 is the simplification of radical 18. Okay, now we need to get rid of the radical in the denominator. So we gotta multiply top and bottom by, well, it's a square root, so we need everything to be a power of 2 on the inside. So since that's 2, we need to multiply it by another square root of 2. So 5 rad 2, 8, all over 3 times square root of 2 times square root of 2 is square root of 4, which is just 2. 5 root 2 all over 6. Okay, 55. I see that's a square root, right? So I gotta multiply top and bottom by the square root of k. Right? Because the denominator will give us k times k, which is k squared. Okay, so we're gonna get 8 square root of 3 times k is 3k all over square root of k times square root of k is just k. Right? Because square root of k squared, you guys, is simply just k. Alright, 56. Now, I'm noticing that I could simplify this denominator already. So, 2 radical 5 are all over, now I'll just do it over here. I know that since this is a square root, right? So it's a root of 2. 2 goes into 3 one time. So that means 1m pops out with a remainder of m. Now we can get rid of the denominator. So I'm going to multiply top and bottom by the square root of m, which equals 2 square root of 5r times m is 5rm all over m times square root of n times square root of m, which is just m times m, which is simply 2 rad 5rm all over m squared. Yep. Okay, that shouldn't interfere with anything. Okay, 57. Alright, so for 57, I'm just going to split up that cube root to both. Now, cube root of 9, right? Well, I can multiply top and bottom by, well, first, right? This has a root of 3, which means everything on the inside must have a power of 3. This is one thing I do notice. Isn't 9 3 to the second power? It is, right? So if 9 is 3 to the second power, and remember, we need this to be a power of 3. Then all we have to do is just multiply top and bottom by the cube root of 3. Because if we do that, we're going to get cube root of 30 all over the cube root of 3 to the third power. And that's simply going to be cube root of 30 all over 3, which is your answer. Okay. So that's that. Now we got 58. Okay, so this one, square root of 32, a to the 5th, b to the 3rd, all over. Alright, I'm noticing that I can already take out this b squared because, right, 2 goes into 2 one time, so I already know a b is going to pop out, and we still got remainders of radical 2a. So, to rationalize this, we need these two to be powers of 2, which means we gotta multiply by radical 2a, which equals square root of, now look at the numerators, right? Look at the numerators. 2 times 32, 64. A times a to the 5th, a to the 6th, b to the 3rd, all over b. Square root of 2a times square root of 2a, you guys, is just 2a. And that's going to equal, now let's look at the numerator, right? Square root of 64 is 8. 6 divided by 2 is a to the 3rd. There's 3 a's. 3 divided by 2, so that means there will be 1 b on the outside and 1 b on the inside. And on the bottom, 2ab. Now we could cancel. So we could cancel this one with that one. An a from both and a b from the top. So our final answer is going to be 4a squared square root of b. And that's our final answer. Okay, 59, right from the jump, I can see that 3 goes into 6 twice, so we're going to have a 2 on the top. And then square root of 5x, right? Which means I have to multiply top and bottom by square root of 5x. Why? Because 5 times 5 will give me 5 squared, and x times x will give me x squared. And we want the powers of 2's to be on the inside to eliminate the square root. Okay, so 5 times 45, you guys, is 225. X to the 4th, all over 5x. Right, because 5 times 5, that's 5 squared. I'll show you guys. That'd be 5 squared and x squared, but remember, this square root eliminates these powers of 2's, so it'll only leave us 5x. Alright, so let's simplify the top. So I'll just do the square root of 225 x to the 4th right here. That's 15 times 15. 5 times 3. 5 times 3. Pair of 5's, pair of 3's, which means on the outside it's going to be 3 times 5. No square root, because 2 goes into 4 twice for x squared. So we're going to get 15x squared for that one. So that's going to be 15x squared all over 5x, which is simply going to be 3x. Oh, I made a mistake. I forgot the 2. Remember, there's that 2 on the outside. So, sorry. 30x squared all over 5x, which is 6x. Alright, this next one. Alright, now we're dealing with cube roots, right? So, if we're dealing with cube roots now, all of these have to have a power of 3. So, what I need to do is I need to multiply the cube root to top and bottom by 2 5, so 5 squared, 2 x's, and 2 y's. Now, on the bottom, we are going to get the cube root of 5 to the third, x third, y to the third. And on the top, we are going to get a very big number. So cube root of 25 times 625, you guys. That's gonna be, yikes, 15,625. X squared times x to the 6th is x to the 8th, and y squared times y to the 4th is y to the 6th. Alright, so we need to simplify this. Well, you already know that this is going to be 25 and 625, right? 5 and 5. 25 and 125, 25, 5 and 5, 5 and 5. Pair of 3's right there, pair of 3's right there. So it's going to be 5 times 5 on the outside, cube root. So this 3, right, goes into 8 2 times, so x squared, and there's going to be 2 remainders. This 3 goes into the 6 2 times, so y to the second. So on the numerator, we're going to have 25 x squared y squared cube root of x squared all over 5xy, because right, the cube root eliminates all of these third powers. Alright, back to here. So now we can cancel 25, and this 5 can cancel. That will just give us 5. We could cancel 1x from top and bottom to just give us x, and we could cancel out 1y from top and bottom to give us just y. Cube root of x squared. Okay. Alright, this next one. Gotta multiply top and bottom by, remember, all of these need a third power. So cube root of, well, I know x times x squared will give me x to the third, and y times y squared will give me y to the third. To top and bottom. Okay, so we're gonna get cube root of 27. X times x squared is x to the third, y to the 7th times y squared is y to the 9th, all over cube root of x to the third, y third, right? X times x squared, x to the third, y times y squared, y to the third. Okay, so let's focus on the top. The cube root of 27 is 3. Look at the powers. 3 divided by 3 will just give us just 1x. 9 divided by 3 will just give us 3y's. No remainders on the inside. Then on the bottom, xy. X cancel, 1y cancels from top. So we're just going to have 3y squared. And the last problem, you guys. Okay, so I see that this 3 and that 9 cancel, so this is going to be a 3. Oh man, it's a 5th power. Eeh. Challenge problem, right? So, alright, so basically, you guys, this is just going to be a ridiculously big number. But it's okay, it's good for you guys to see a challenge problem here and there. So, in the denominator, right, we need all of these to be powers of 5. So that means 5 times 5 to the 4th would give you 5 to the 5th power. X times x to the 4th would give you x to the 5th power. And y to the 2nd times y to the 3rd will give you y to the 5th. And it has to be the same up here. Okay. So, this is going to equal... Now let's multiply the tops together. So 5 times 5 times 5 times 5 times all of that. Ooh, a nice 100,000. 5th root. X to the 8th times x to the 4th is x to the 12th, and y to the 11th times y to the 3rd is y to the 14th. All over 5th root of, right, 5 to the 5/4, 5, x to the x/4, x5, y squared to the y3rd, y5. Okay, so focusing on the top, let's do that down here. 100,000. That is a nice clean number, so we could do, right, multiple things. So I'll just do 100 and 1,000. 10, 10. This one I'll just do 10 and 100. 10, 10. Now, if some of you notice, I see that I have 5 10s. You can certainly take out a 10 here, or if you guys just want to do the more traditional, right, all of these are 2 5s. But look at the 2s. 1, 2, 3, 4, 5. 5 2s, that means a 2 comes on the outside. Group of 5, right? 1, 2, 3, 4, 5. 5 5s, so 5 gets to come on the outside. Now let's just look at your exponents, right? 5 goes into 12. 5 goes into 12 2 times. So you're going to get x to the 2nd, 5th root of x squared, because there's 2 leftovers. And 5 goes into 14 2 times as well. Y squared, and there's going to be 4 leftovers. Y to the 4th. So that means it simplifies to 10x squared, y squared, 5th root of x squared, y to the 4th. Okay. Equals. Now that was the simplification of the top. Now on the bottom, remember this 5th root cancels off all those 5 powers. So 5xy. And now we could cancel 10 and 5 cancel, so that means we just get a 2. 1x cancels from both, so we just get an x. And 1y cancels from both, so we only get a y. 5th root of x squared y to the 4th. And of course, you guys, I forgot, see this 3, I forgot to put this 3 there, 3 there, 3 there, 3 there, which really means we get 6xy, 5th power of x squared y to the 4th. as you guys can see, don't forget the when you cancel off for the 3. And that's about it. Okay. So, next we're going to do these conjugates, you guys, and then equations, and then we'll be done. Alright. Peace.